Today we're going to be talking about applying the product rule and the quotient rule. Let's look at this first function, y is equal to x squared times x cubed. Now it seems like we could be able to just find the derivative of x squared and the derivative of x cubed and multiply those together, and that would be the answer. And so let's try that. If I take that approach, the derivative of x squared is 2x, the derivative of x cubed is 3x squared. And if I multiply those two things together, you see that we get 6x cubed as the derivative of that function. Now let's take a different approach. What if I rewrite this? Instead of writing it as x squared times x cubed, let's go ahead and multiply those together and rewrite it as x to the fifth. Well, in that form, if I take the derivative, we know that that derivative is 5x to the fourth, which is not 6x to the third. And so this is a great example to show us that just taking the derivative of each of two things that are being multiplied together, it does not work to get the derivative. We have to use what is called the product rule. And the product rule looks like this. The derivative of f of x times g of x is equal to f of x times g prime of x plus g of x times f prime of x. In other words, the first function times the derivative of the second plus the second times the derivative of the first. Now sometimes it looks a little confusing with all these of x's in there. We can write this using shorthand notation. Derivative of f times g is going to be equal to f times g prime plus g times f prime. And that's the version of this rule that we're going to add to your flashcards and your foldable, the version that I want you to memorize. So let's see if we can use this rule with this first example. Y is equal to x squared plus 1 times x cubed plus 4. Now what I want to do on this first example is just list out all these different parts that we need to plug into the rule. This first function here is going to be f. So f is equal to x squared plus 1. And if we have f equal to x squared plus 1, then of course f prime is 2x. The second function, we're going to call it g, and g is equal to x cubed plus 4, and then g prime would be equal to 3x squared. So now I have all the parts that I need for my product rule, and so I'm going to plug them in. The derivative of y is going to be equal to f times g prime. Well, f is x squared plus 1. G prime is 3x squared plus g times f prime. G is x cubed plus 4, and f prime is 2x. Again, that's f times g prime plus g times f prime. And then once we get it into this form, we need to simplify things a little bit. The derivative is equal to, if I distribute this 3x squared, we get 3x to the fourth plus 3x squared. And in my second term, I'm going to distribute the 2x plus 2x to the fourth plus 8x. And simplifying one more time, collecting like terms, 5x to the fourth plus 3x squared plus 8x. And that would be our derivative of y, equal to x squared plus 1 times x cubed plus 4. Let's look at another example. Find the derivative of this function. F of x is equal to x to the fifth times e to the x. So in this example, you can see we have two functions here being multiplied, so we must use the product rule. And I'm just going to rewrite the product rule here for us. F prime, and in this case, this f prime is referring to this f, which just means our derivative is going to be equal to f times g prime plus g times f prime. This first function, x to the fifth, we're going to let that be our f function. So f is equal to x to the fifth, which means f prime would be 5x to the fourth. E to the x is our g function. So g equals e to the x, and g prime is also e to the x. So then if I apply my product rule, f prime is equal to f, which is x to the fifth, times g prime, e to the x, plus g, e to the x, times f prime, 5x to the fourth. And with this product, this application of the product rule, there's really no simplifying that we can do here, so we can just leave our answer in this form. Let's look at one more example together. Y equals e to the x over x cubed. Now notice this time it's not written as a product, this is written as a quotient. But we can rewrite it as a product because we know how to rewrite that denominator. This is equal to e to the x times x to the negative 3. Now this time I'm going to apply the product rule without listing all the parts out on the side. We don't need to do that all the time. Once you get used to using the product rule, you can just kind of figure those things in your head and do those parts as you go along. I'm going to write the rule one more time to remind us. dy dx is going to be equal to fg prime plus g times f prime. In this case, my f is e to the x, my g is x to the negative 3. So f, e to the x, times g prime, so I need to do the derivative of g, which would be negative 3x to the negative 4. So that's f times g prime, plus g, which is x to the negative 3, times f prime. F is e to the x, so of course f prime is also e to the x. And then we could rewrite this without negative exponents. I would have negative 3 e to the x over x to the fourth plus e to the x over x to the third. Let's move on to the quotient rule. Quotient rule is just a little bit more complicated than the product rule. If we're taking the derivative of f divided by g, the derivative is going to be equal to g of x times f prime of x minus f of x times g prime of x over g of x squared. Now again, we can write this without all of the of x's. Derivative of f divided by g is equal to g times f prime minus f times g prime over g squared. Now notice, because we have a minus sign in this rule, the order is very important here. You have to start with g times f prime minus f times g prime. In the product rule, because we're adding, it doesn't matter which one comes first. Order doesn't matter when you're adding, but when you are subtracting, the order is very important. So make sure that we always start with g times f prime minus f times g prime over g squared. Let's look at a couple examples. In this first example, my top function is going to be f, and the denominator function is going to be g. So I'm going to list my parts out over here for this first example. F is equal to 3x minus 2. F prime is equal to 3. G is x squared plus 1. And so g prime would be 2x. Now I'm doing this here right now just to be clear about what I'm doing. If listing the parts out to the side helps you, then I want you to continue doing that. But if you can do these things in your head while you go through the application of the rule, that's really good as well. Let me write my rule again up here so we can reference it. The derivative of f over g is equal to gf prime minus fg prime over g squared. So I'm going to start with g times f prime. My g is x squared plus 1. F prime is 3 minus f times g prime. My f is 3x minus 2, and g prime is 2x. And this is all over g squared. G is x squared plus 1 squared. So let's do a little bit of simplifying here. I'm going to distribute the 3x squared plus 3. Here's the tricky part of the quotient rule, and a place where students often make mistakes when simplifying with this rule. We have a minus sign here, which must be distributed to both terms that are in that parentheses. Personally, I like to change it to a plus and go ahead and change the signs of both things that are in the parentheses, just to make sure that I don't forget to distribute it. I am going to distribute the 2x as well. 2x times negative 3x would be minus 6x squared, and 2x times positive 2 or plus 2 would be plus 4x. And then your denominator, there's no need to multiply that out. We can just leave it in the form x squared plus 1 squared. So let's do one more step of simplifying. Let's combine like terms here. Negative 3x squared plus 4x plus 3 over x squared plus 1 squared. And that's our final answer. That's the derivative of 3x minus 2 divided by x squared plus 1. Let's look at one more example. 5x squared minus 3x over the square root of x cubed. Now you may remember earlier I did a example using the product rule where we rewrote the denominator as an x with a negative exponent. And you could do that in this example as well, but I'm going to go ahead and use the quotient rule to find this derivative. Remember that my numerator is f, my denominator is g. And we really need to rewrite that square root of x cubed so that we can do the derivative. So out here to the side, our g is actually equal to x to the 3/2 power. Remember, if it's square root, if there's no number here, it's a 2, and that 2 becomes the denominator of the exponent, the fraction exponent. Again, I'm going to write our rule just so we can reference it. dy dx, the derivative, let me start that over. The derivative of f over g, here we go. Derivative of f over g is equal to g f prime minus f times g prime over g squared. Again, remember to get that g f prime first. Order matters here. So my derivative is equal to g, which is x to the 3/2 times f prime, or the derivative of f, which in this case would be 10x minus 3, minus f times g prime. F is 5x squared minus 3x, and g prime would be, using this rewritten version of the function, 3/2 x to the 1/2 power. 3/2 minus 1 would be 1/2. And then, of course, this is over the square root of x cubed squared, or you could have written that as x to the 3/2 squared as well. Either form would be okay. Now we're going to go ahead and simplify this a little bit, challenge our algebra skills just a bit. I'm going to distribute x to the 3/2 to both of these terms here, remember that when we're multiplying, we're going to add exponents. My x here has an exponent of 1. So x to the 3 halves times 10x to the 1 is going to be 10x to the 5 halves. 3 halves plus 1 would be 5 halves. Minus 3 times x to the 3 halves. Let me rewrite that again so you can see it. This minus, we need to distribute again. I'm going to change colors and go ahead and distribute it. Make that negative 5, or make the 5x squared negative. Make the minus 3x a plus. And I'm distributing 3 halves x to the 1 half. I'm distributing it to both of these terms. So I'm going to have minus 3 halves times 5 would be 15 halves. Think of it as 5 over 1. Multiply your numerators, multiply your denominators. 3 halves times 5 is 15 halves, x. And then remember we're adding exponents. 2 plus 1 half would be 5 halves. And then 3 halves x to the 1 half times 3x. Again, 3 times 3 is 9 over 2. X to the, and 1 plus a half would be 3 halves. And this is all over, actually the square root and the squared would cancel out and we just have x cubed. And let's see if I can fit one more. Let's combine like terms. 10x to the 5 halves minus 15 halves x to the 5 halves. That would be 5 halves x to the 5 halves, because 10 would be 20 over 2. 20 halves minus 15 halves would be 5 halves. And then negative 3x to the 3 halves plus 9 halves x to the 3 halves. 3 would be 6 halves. So negative 6 halves plus 9 halves would be plus 3 halves x to the 3 halves. Interesting how that worked out. And of course all of this is still, I'm kind of out of room at the bottom of my board here. All of this is over x to the third. Now if you got a little lost in the algebra simplifying there at the end, that's okay. The point of this lesson is this step right here, to be able to apply the quotient rule.